Now, a new addition as well is the variable density solver, and this is a little bit of a different approach. Essentially, it's just another step in the right direction where Fume's now starting to add additional controls to kind of give you a lot more control to how your fluids interact with each other. So I've set up this quick scene, and it's literally just some particles, ignore the preview, but it's just some particles kind of firing at each other. And so we have these particles doing that, and I'm not simulating any fuel, I'm just going to simulate smoke. Alright, and the idea here is that, let's bring these down, is that I'm going to simulate the fluids of these particles coming at each other. And right now they're of equal value, and so obviously when two fluids interact, they're going to well, obviously interact and push each other around. Now, if you're dealing with real flow, for instance, just because it's a common commercially accessible package I can reference here, if you had two particles hitting each other, you would control which one has more strength based on the value of density. So one might have a value of 1,000, which is the density of water, whereas the other one might have a lower value, simulating it's more of a lighter liquid or whatever. And if that is the case, what would happen is one is going to, like the water would push the other one away, or if the other one's more concrete, it might push the water away. So you've got control over how much influence one has physically over the other based on that. Now, in this case, we don't. Like FumeFX, it's one solver, so it's one window, so there isn't any value of density technically in your actual fluid. So how can you control which one is denser than the other? As we can see here, they're both interacting, they're both hitting each other, and they're both essentially just interacting because they're equal. So what the variable density solver does is if I enable this, is it allows me to assign other attributes as to, okay, well, the density can be controlled by various different influences. So for instance, if this was smoke that I want to deal with, then I can have my source 1. I can go down to smoke, I could set this to be a value of 10. Now I could set my second one to be 2, as it is here. And it means that either way, the other one's going to be 5 times stronger than it is. So under smoke, I have the VD multiplier, and I could say, okay, well, the volume density multiplier, I can control how much strength they have based on the smoke. And when I run this, essentially it just means that one is going to have more power over the other. Essentially one is a higher density, and this can either be done through using smoke, or you can use temperature as a way to control this influence. If you want this to be equal, then you can always set the multiplier to be 0. So it's just a way to kind of keep that in mind. But as we can see now, the density is definitely a lot more stronger on this side, and that is just a really subtle way to kind of get that extra interaction. And this is something that can cause slower simulation times. Because it is calculating a lot more. I'm just going to lower the densities of this a little bit so we can see it a bit better. Again, this is low resolution as I'm doing a sim. But as we can see, the thicker stuff definitely has more influence.